Okay, guys, so let's talk about Unit 2, Lesson 3, called More About Constant of Proportionality. Now, of course, I'm not going to go over the warm up with you guys, but always make sure you visit your Google Classroom and complete your warm up in assessments. Okay, so I'm going to start this lesson off with this student task called centimeters and millimeters. You guys can read quietly to yourself as I read this out loud. It says, there is a proportional relationship between any length measured in centimeters and the same length measured in millimeters. There are two ways of thinking about this proportional relationship. Number one, if you know the length of something in centimeters, you could calculate its length in millimeters. Complete the table. What is the constant of proportionality? Okay, so in our last lesson, we was kind of introduced to the constant of proportionality, but in today's lesson, we're really going to dig deep into it and how can we use it when completing these proportional tables. So I see this ruler, and it's a centimeter ruler, and what I see is one side is the centimeters, the other side is the millimeters. Okay. So what I want to do is I want to find a relationship between these two quantities, okay? So when I see there is 1 centimeter, there are 10 millimeters. So I'm going to point to this ratio set right here. So whenever they have 1 centimeter, there is 10 millimeters. Whenever there is 2 centimeters, there's 20 millimeters. Whenever there's 3 centimeters, there's 30 millimeters. Whenever there's 4 centimeters, there's 40 millimeters. And whenever there's 5 millimeters or centimeters, there is 50 millimeters. So the first part of the question is telling us to complete this table. Now it's asking us whenever there is 9 millimeters, what would, not millimeters, but centimeters, whenever there's 9 centimeters, how many millimeters would there be? So if we're studying the relationship between the centimeters and the millimeters, it appears that how many there is centimeters, you want to multiply that number times 10. And here's what I mean by that. So 1 times 10 would be 10. 2 times 10 will be 20. 3 times 10, can you guess it? 30, and so on. So what do we want to multiply 9 by? If you guess 10, you are absolutely correct. So if there are 9 centimeters, there will be 9 millimeters. You could also set this up in ratio form. You could have put 1 centimeter to 10 millimeters. And then you could, okay, it jumps all the way to 9 centimeters. What's the missing amount of millimeters? Okay, so let's look at the next one. What can I multiply 12.5 by to figure out the millimeters? If you guess 10, you are absolutely correct. So it's going to be 125 millimeters. So then the next one is saying 50 centimeters, okay? 50 centimeters. Now, when I see that there are 5 centimeters, there is 50 millimeters. But how many millimeters would I have if I have 50 centimeters? If you guess 500, you are absolutely correct. All right. So what would I multiply the last row by? 88 and 49 hundredths. Can you guess? If you guess multiply by 10, you are absolutely correct. So this would be 884 and 9/10. Okay? So if I had to determine what is the constant of proportionality, I want you guys to think, what number did I use to help me complete this table? What was the star of the show? What number did I use, or what number did I multiply? If you guess 10, you are absolutely correct. 10 would be the constant of proportionality. Okay, so let's move on to the next part. Number 2, it says if you know the length of something in millimeters, you can calculate its length in centimeters. And it's asking us to complete the table. Now, if you notice, and I'm going to highlight that so you guys can see this, millimeters is now in the left side of the table, okay? Whereas in the first exercise or the first question, it was on the right side. So now I need to figure out how many centimeters would be. So let's reference back to question number 1. We know that whenever we had 1 centimeter, we had 10 millimeters, and so on. We multiply by 10. But how many centimeters would it be? Would 70 millimeters be? So just think. If we multiply by 10 in this table, what do we have to do in this table? What do you think we will have to do? And remember, let's remember the relationship. I want to write the ratio down. So 1 centimeter would be from 1 centimeter to 10 millimeters. But now the order of the ratio has switched to 10 millimeters to 1 centimeter. So what can I multiply 10 by to get to 1? Now you may have to think about the 6th grade lessons that we did. Now if you're at your computer screaming out divided by 10, you're kind of close, okay? You're kind of close. What we're actually doing is multiplying by 1/10. This is called the multiplicative inverse, okay? Because when you divide by 10, it's the same as multiplying by 1/10. And whenever you have a relationship between these two columns right here, it's always going to be a multiplicative relationship, okay? It's not going to say, oh, it's division. No, it's multiplication. So when I multiply that going across, I should get 70 over 10, which simplifies to 7. I'm going to multiply the same thing to each row, to each number in this column, which will be 245 times 110, which is going to be over 10. Now, if you know your powers of 10, you know that this is 24 and 5/10. But if you don't, you can always do some long division on the side. And you know that 10 will go into 24 twice. And then you drop the 5, and then it's going to be, 40. Just want to show you guys, where that came from, just in case I have some kids that don't get it. All right? And it's going to be 24 and 5/10. Now I want to do the same thing with this one, which would be times 1/4, times 1/10, which would be 4 over 10. Now you can leave the fraction the same way, but why not simplify since we've been simplifying every fraction? You could turn it into a decimal, which is 0.4 or 4/10, or you could turn it into or leave it as a fraction, which would be 2 over 5 or 2/5. Okay. Then for the last row, we could do the same thing, which it's already in a decimal. It's just simpler just to move that decimal up, which is just a little math trick. Divided by 10, and it would equal, there we go, 69 and 91/100. Okay, so for part B, it's asking us what was the constant of proportionality. So what number helped us figure out the values in the right column? What number was constantly multiplied each time? If you guess that the constant of proportionality is 1/10, you are absolutely correct. Okay, the constant of proportionality is 1/10. If you like decimals, you could have put 1/10. Okay, so how are these two constant of proportionalities related to each other? So the two constant of proportionality, which was the stars of the show, was... Ooh, I'm trying to change my color and it don't want to let me. There we go. It was 10 and 1/10. How are they related? What are they considered in the fraction worlds? If you guess they are reciprocals, you are absolutely correct. Okay, they are reciprocals. And the new word is the multiplicative inverse. To each other. Okay, so to convert the centimeters to millimeters, you can multiply by 10. To convert the millimeters to centimeter, you could divide by 10, okay? Or you can multiply by 1/10.